This is FE Peer Review. The date is the 1st of November 2023. First, a booboo, and then more fun with circles and spheres. In my previous video, a cricket sits on a beach ball. What does he see? I made a little booboo, and somebody in the comments named Cinnamon Control, who I will refer to as they and them since I don't know how they prefer to be referred to as, pointed out that I may have been mistaken in a certain spot on the video, and I came to the conclusion that this was true. So I'm first going to point out the error and fix it. So here's our original diagram, and what I had done was I had a point off to the far right, and I traced a line from that point such that it would cut through the circle and thus form a chord in the circle. I then divided that chord in half and took a perpendicular, which, by the way, passes through the center of the circle, and took the intersection of that perpendicular to the perimeter of the circle and said that's the tangent point for a line originating over here at the far right corner, at the far right end of the screen. And that's not quite correct, because what we'll find is that this line, if it is to be tangent to the circle, that means at a 90-degree angle to this radial line, that makes it perpendicular, and that makes it parallel to the original line we drew. And those two parallel lines can never converge, which means they can never pass through this same point over here. So I saw that and I saw, aha, problem. So I traced another one just to kind of accentuate the problem. Let me break that line in two parts. Take this, rotate it about its center point 90 degrees. That'll give me a radial line. Erase that. So this is the same setup as we saw up above, but I'm just exaggerating the problem by making a longer chord. And now I can take this, make a copy perpendicular that remains parallel to the original. And yeah, we see that they're never gonna meet. This line's never gonna go through this point. So the tangent from this point can't be this spot here. It's got to be somewhere to this side of it. So this technique that I had learned ages ago, probably from a carpenter back when I was in my teens, doesn't actually work. Now, it does gradually approximate a tangent the smaller you make your chord. Let me get rid of that. The smaller you make that chord, the closer you get to finding the actual tangent, which is nice. But the other problem is the smaller you make that, the harder it is using traditional drafting techniques to find the center of that line accurately. So you're introducing more error as you make that smaller. So it's okay. Maybe it's good enough for certain situations, but it doesn't work. It's not good geometry. So we're going to forget that ever happened. But while I'm here, I have all this stuff on my screen, I'm going to show you a fun little thing. We're going to forget about that whole tangent business right now. And this was another little technique that I learned at that time, which I'm happy to say is correct. I double checked it before doing this video. Now let's say you have a circle, but you don't know where the center is. Get rid of that. And you want to find the center of your circle. This was another little technique that I learned, and I'm pleased to say it is correct. I've just drawn a chord there. I'm going to rotate that chord about its center point, 90 degrees. Then I'm going to draw another random chord line somewhere else. I'm going to rotate that 90 degrees. And where those two intersect is my circle. Is the center of my circle. So that's the center point of my circle. That was one little trick I learned back then. It's the kind of thing that comes in handy when you're doing certain construction operations, like you need to set out a pipe, a penetration in a wooden wall for a pipe. You don't know, you know the size of the pipe, but you don't know exactly where you want to trace the circle on the wall. So this is a way to find a center point and get you going on a good spot. In my last video, I had also received a suggestion, sort of a request, that I might try to figure out how to impose a map onto that sphere there. And I haven't been able to figure out how to overlay an image onto that curved surface. But I did track down a model somebody else had made of a globe. So let's pull that up here, an actual desk globe. It's a little bit rough, but it'll serve our purposes. The idea was to take this circle up here and overlay it onto a globe that shows the continents. What we're seeing here is this visible surface of the Earth from the ISS. That little line right there, a little black line that ends right there, that represents the height of the ISS above the surface of the Earth, and the circle would be the tangent from that top point there. In other words, as far as you can see of the Earth from the ISS. As you can see, it's a relatively small compared to the total. So what I'm going to do to superimpose that on our globe here is I'm just going to take the ratio of this diameter to the total diameter and create something of a similar scale, because these two models are two very different scales. So I'm going to take this one up here. I'm going to take this distance, let's see, from here to here, 3938, 3937. I'm just going to pop that into a calculator here to keep track of it. 3937. Let's go back to our globe and get the full diameter. So this distance, as I drew it, $12,742 divided by 12,742. So that makes it about 30.1%. Well, moseying back over to our very crude globe here, we find that the diameter of this globe, measuring from two convenient spots, the distance at that point to that point is 800 millimeters. So that's the diameter they used for theirs. And we're going to need one that's 30% of that. So that's going to be a circle that's 240 millimeters in diameter. So 120. Let's make this look a little nicer. Put a little crosshair in the middle of it so we can move it around more easily. Put it where we want it. And let's see, let's drop it in a few places. We'll start by we'll put the center of it over Paris. I like Paris. It's an alright town. Oh, that's pretty close. Let's make it transparent so that we can see the surfaces under it. So ISS over Paris seems to cover all of Western Europe and well into Eastern Europe and even a bit of North Africa. That covers a larger area than I expected. Must be quite a view. Well, let's do one over North America. Well, drop it over somewhere right in the middle of the country. We'll pick that spot there. All right. It's not perfect, but it's good enough. We've got it over Denver, Colorado, roughly. And we can see all the way out to the west coast. This is bigger than I realized. Somebody probably ought to check this and see if I did this right. Can you really see that much of the surface from the ISS? We've got from the west coast all the way to Chicago. And from partway down Mexico, not quite Mexico City, all the way well up into Canada. Of course, a lot of it is going to be hard to see because it's going to be that distant edges over there. Kind of like trying to look at the horizon from an airplane and make out land masses in the far distance. It's a lot harder when it's just directly under you. Anyway, let's do one more. For good measure, we'll put it on Australia in honor of the wolf pack. Looks like you've got a pretty good view of the entire landmass of Australia there. Again, that's more than I expected. Anyhow, that's what the numbers tell me. Numbers can be mistaken. So if anybody feels like checking, that'd be great. Well, that's all for this video. It's kind of a disorganized mess. But I hope we cleared up a couple of points and had a little fun along the way. I wish you all a good night. We're having a big storm rolling in here right now. My thoughts go out to the folks in the southwest of England. I'm in Brittany, which is just across the channel, and we're getting edges of it, and it's bad enough. So y'all take care and stay warm and safe. Talk to y'all later.